All right, continuing with some series. We're adding up all of these numbers from plugging in 1 to plugging in 37. And so let's plug in, when you plug in 1, you get 3 times 1 plus 2, which is 5. When you plug in 2, you get 3 times 2 is 6, plus 2 is 8. 3 times 3 is 9, plus 2 is 11, and so on. So 5, 8, 11, 14, so on and so forth. Until you get to 37, and 37 times 3 will give us 113. So the first term, last term, this is an arithmetic because it's adding 3 every single time. 3 is the common difference. So the sum is, once again, number of terms divided by 2 times our first term plus our last term. 5 plus 113. Those are going to add up to the same thing if you continue moving inwards. 37 over 2. It still works even if you have an odd number. And so that adds up to 2,183, all 37 of those numbers. But because we're using a pattern, it helps. This one is going to be geometric, it's raised to a power, but if we plug in 1, we get 3 times 4 to the 0, plus 3 times 4 to the first, so on and so forth. That's 3 plus 12 plus 48. This is geometric, and so what we're doing is we're going to use a sub 1 times 1 minus r to the n, 1 minus r. Our first term is 3. 1 minus our ratio, continue to multiply by 4 every single time, raised to the 6th power, because we have 6 numbers, over 1 minus 4. $4,095. This is 3 times all that. The next one does something very similar, except when you plug in negative 3 to the first, you get negative 3. Negative 3 second, you get 9. And so this one's flip-flopping between positive and negative. This one only has 4 numbers, but you can still use the first term being negative 3, 1 minus r, which is negative 3 raised to the 4th. So that'll end up being positive, and 1 minus a negative 3. So either way you cut it, you should get 60. And in this next one, we're going to add up the numbers from 0 all the way to infinity. And so this is what we call an infinite geometric. Infinite. Because we're never going to stop adding. And so we're going to use the fact that if you use this equation up here, anytime r is less than 1, this is going to go to 0. If you multiply by a number less than 1 and you do it infinite amount of times, this is going to go to 0. So you end up with an equation that looks like this. A sub 1 over 1 minus r. So our first term, when you plug in 2/9 to the 0 power, because we're starting at 0, you just get 15. Plus 15 times 2/9 plus 15 times 2/9 squared, and so on. And so we're just going to, since r is less than 1, 2/9 is less than 1, it has a sum. And so our first term is 15, divided by 1 minus 2/9, 7/9. One 35/7. And another infinite geometric, but in the form of the story problem. So we've got a pirate ride, swings back and forth. The first time it swings 75 meters. The next one is 2/5 as long, so 75 times 2/5 repeatedly. Times 2/5 times 2/5, so 75 times 2/5 times 2/5 times 2/5. So we're going to get 30 and 12 and 4.8 and so on and so forth. So if it continues to swing back and forth, and assuming it didn't have a brake on it, this is just some friction involved, assuming that it never ever stops swinging, it's going to swing infinitely long. And so this is going to keep going, and so we're going to use that same sum equation that we used up here. So a sub 1 over 1 minus r, our 75 over 1 minus our 2/5. So 75 over 3/5, 75 times 5/3. 75 over 3 cancels out to 25 times 5, which is 125 meters. And there we have it. That is the total length, total distance the ship's going to travel. Happy studying. Good luck on your tests.